So welcome everyone to our talk on virtio-fs. I'm Hannah, that's Herman. And first, we're going to talk about virtio-fs in the present, basically. Current projects that we're working on, which include live migration and the integration with other projects. And then before giving an outlook on future plans, Herman will also give an introduction to virtio-fs from a technical perspective, basically, which will be interesting to you if you're looking to implement your own backends for virtio-fs, which are not virtio-fsd. So maybe you don't want to just share normal directory on the host, and then you write your own backends, and then this will be interesting to you. So virtio-fs allows you to share a directory that's on the host with the guest, simple as that. To do that, we have the daemon virtio-fsd, which has access to the shared directory and then exposes it to the guest through a virtio-fs device using the virtio-fs protocol and the fuse protocol wrapped into each other. And then in the VM guest, you have a client who accesses this device and thus gets access to the shared directory, and that's it. So when you run virtio-fsd, there are a couple of options you should be aware about. I think most of the options are fairly well explained in the README, but there are some options that you should really set probably because they're important and virtio-fsd cannot figure out a good default generally for you. So one of these, for example, is caching. Caching is always a trade-off between safety and performance. And so, well, virtio-fsd doesn't know what safety you need. Of course, you always need the best performance, but safety is up to you, basically. So you need to tell it basically what caching guarantees you want. Like you can set disable caching altogether, simple as that. And then, well, every call from the guest, everything that you do in the shared directory has to go through the whole device, through the whole stack, so that's rather slow. But you'll see every update on the host immediately, so everything's very safe. Alternatively, you can set the caching to auto, which I also think is the default. In this case, metadata in the guest will be cached for a second, so you'll see updates rather quickly, but not immediately. And you'll have a default, and you have read cache for files. So if you're modifying files concurrently on the host and the guest, this might already cause problems then. With cache equals always, this cache is also kept when you close a file on the guest. So you can't just then close a file and reopen it to see changes on the host. That won't work then anymore. And basically every metadata, all metadata is kept indefinitely. So yeah. And finally, if you basically only if you have complete exclusive access to the shared directory by a virtual machine, you can also enable write-back caching, which gives you even more performance. But if you don't have exclusive access to a file and someone else modifies it concurrently, like that's really bad, because then the cache gets out of sync, the VM flushes it back, and then you might get data corruption. So really only use this when you are sure you can. Another option that we have is inode file handlers, which requires a bit of context, but this will also be important later on. So how we address inodes in the shared directory is through these fuse inode IDs. So every inode gets an integer ID when the guest first sees it, looks it up basically. And when you want to do operations on it, you need the integer ID as the primary identifier. It's an ID. And so virtio-fsd must generate these IDs when the guest walks through the shared directory. And then it must also be able to open these inodes again when you just pass the integer ID to it. So we need to keep some mapping of these integer IDs to inodes. And the question is, how do we represent these inodes? How can we open them just from the ID? And there are two ways we have. First one is the file descriptors. So when the guest walks to the shared directory, we open the file descriptor, and we just keep it. And then later on, we can work on this, operate off of this file descriptor. And that's very simple. The problem is it's a file descriptor. So first, it counts against virtio-fsd's file descriptor limit. So there's a count limit that you have. And if you hit that, well, the shared directory is too big. So that's too bad then. The second problem is that it keeps files open. So if they're unlinked, for example, well, the data will not be deleted immediately, right? How it is with file descriptors. And this might cause special problems with NFS, like NFS v3, where you have silly renaming. So when you delete a file, NFS cannot really delete the inode. So we'll rename the file to be a hidden file, and that's maybe not great for you. So in these cases, alternatively, you might want to use file handles instead to represent inodes. How these work is basically they're just pure data that point into the inode table of a file system, and then you can hand this data to the file system, and it will later open the inode for you immediately. So the advantage is it's just data, so it doesn't count against all these caps. It doesn't keep the file open, but the disadvantage is that it requires basically root privileges because it requires this very heavy-handed capability, captech read search, and also file system support. But the file system support basically is a given because most file systems support this. But the root requirement, of course, is something that you generally cannot assume there is. So you need to set this based on your use case. Like if the file descriptor limitations are a problem for you, then well, you want to use file handlers probably, and then you must ensure somehow that virtio-fs also runs as root. If you can ensure that, well, you should switch off file handlers. You can also just let virtio-fs figure out whether file handlers work or not, but better set it explicitly. Okay, now let's talk about something more interesting, live migration, because that's always interesting. So the question is, why is live migration a problem for virtio-fs? The problem is that we have internal state. I just talked about this mapping of inode IDs to inodes, and we also, of course, have file descriptors for every file that the guest is open, and we want to do IO through it. And the thing is, we need to transfer state to the destination and restore it there. So we have two problems there. First of all, we need to turn this state into data. And second, we need to move the data to the destination. We need a serialization problem and we have a transfer problem. The second one is simpler, so let's talk about this first. We can just give the data to QEMU. So QEMU already has a migration channel. We have a connection to QEMU, so let's just give it the data. QEMU puts it in the migration channel, and we're done, basically. There's several advantages. First of all, we don't need any additional configuration in virtio-fs, so we don't need to point it to the destination explicitly because it has the connection to QEMU. Second, no additional privileges required to open a network connection because we already have the connection to QEMU again. And then QEMU has some nice features for the migration channel, like migration to file, for example, and we all get these for free if we just let it handle this transfer. This will require an extension to the VOS user protocol, of course, to transfer the data across, but I mean, nothing that's unsolvable. The serialization is a bit harder and comes with its pitfalls, basically. So the question first is, we have these two internal parts of our state. The first one is the mapping of inode IDs to inodes. We've already seen that inodes can be represented through file handlers. They're already data, so we can just put them into the migration stream as they are. The problem is, first of all, again, requires root privileges on the destination to use the file handlers. And second, file handlers are only valid on the very same file system that you generated them on for the very same directory that you generated them on. So you can only migrate virtio-fs if you are using the exact same directory between source and host. So for example, with shared storage such as NFS. If these requirements cannot be met for your case, then we probably have to use file paths instead. The idea here is basically we walk through the whole shared directory, we look at all inodes, and we compare them to our internal database, and we thus find some path to the inodes we have. For every inode we have, we find some path that works, and then transfer this to the destination, and then we use the path to open the inode again. This would allow you to migrate between different file systems, different shared directories, just need to be copies, basically. Doesn't require root privileges, but, well, if you're migrating between different directories, then you have other problems like external renames, for example, where basically it's a time of check to time of use problem, right? You generate the file path, and then the file on the destination is renamed, and then the destination can't find the file, so that's too bad. So basically, both of these approaches come with their pitfalls, so we'll need to implement them both eventually. We're currently focusing on the second one, but we will implement both. And then it's up to you, the user, to figure out which one of these best fits your use case, and then you'll have to choose. Basically, the question is, do you have a single shared directory between source and destination? Probably should use file handles, otherwise probably should use file paths. Now we have the other part of our internal state, which is open files, and that's even funnier because, well, they are file descriptors, so we really need to get these across to the destination. But you can't, like you can't get a file descriptor across a network connection. So the idea is to take the inode ID and the open add flags used for it, and well, reopen that on the destination and repeat the open process. But that's, of course, a problem if the file's been deleted in the meantime, or if its permissions have been changed, because then the destination will not be able to repeat your open process. And the question is how to solve this. The answer, we're not sure yet. Like, this is definitely something that will be not solved in the first iteration that we release of live migration. So these will be limitations at first, and then later we'll have to get creative. Maybe take a leaf out of NSF's book, try something with silly renaming, I don't know. But we'll try creative solutions, definitely. But a completely different approach can be taken if you have a very special case where you just basically, for example, want to upgrade QEMU. So you have one host, want to migrate from one VM to another, but you don't care about virtio-fs at all. Like, it can stay where it is, it can stay the same, you don't need to transfer any data there. In this case, you can just keep the data there and basically disconnect it from the source, reconnect it to the destination, and be done. All the FDs are safe in there, so none of these crazy problems will happen to you. And in this case, you might want to have a look at the external migration work from Anton Kucin, which would allow this. And with that, I hand over to Hermann.
So, who is using this? Basically, currently it is also kind of a critical part of Kata containers, virtio-fs, and also is used by Core OS assembler to build the images. But I want to highlight a couple of use cases that we have that I find interesting. One is Dracut. Now is virtio-fs is included in Dracut, so you can in the command line kernel you can say, okay, I want to run this virtual machine from this directory. So the QEMU only needs to access the kernel init.rd, and you instead of using an image like qcoid2 or something, you can directly boot in from a directory that is sharing using virtio-fs, for example. I think it's kind of similar to what Kata does. And now it's also integrated in systemd, the ftab generator. You can do the same, but not only for the root file system, but also for any other mount points, like for example, home. And that is, I think, is interesting, especially from the Dracut part. If you need to develop like a kernel code, now also kdump supports virtio-fs, so you can generate dumps directly in the virtio-fs directory. So that's nice, very convenient. Also kubevirt. Now you can share config maps, secrets, network APIs, and service accounts, persistent volumes using virtio-fs, and that is nice, especially in the first cases. They share config map, secrets, and the rest of resources, because the previous method was using is.io image, like a CD-ROM disk image. So they were copying all the data in that image and that's exposing that to the VM. And if that information changed, that for example, the secrets of the service accounts also can expire by time, etc., you will not see that propagation of the change inside of the virtual machine. But with virtio-fs, we solve that problem. And also we can use the previous one, the support in Dracut, to use to say kubevirt to boot from a persistent volume, for example. So that's nice. This is one way, for example, the thing that we add is the file system device, that you need to define which one is your volume, and that will be automatically exposed to the VM. How virtio-fs works? Well, virtio-fs is a fuse file system. I will try to explain very briefly how that works. So first, I want to explain a little bit how fuse normally works. So when you have a user space application that does some file system operation, will be first handled by the POSIX file system layer in the kernel, and then it will call the fuse client in the same kernel. And the fuse client will send some fuse operation using the fuse protocol to the fuse daemon in the user space via the fuse character device. So basically, that is the normal flow of the communication between your application and the fuse daemon in the user space. And the thing is, everything is in the same machine. Let's say both the user space size and the kernel size is in the same machine. In case of virtio-fs, since it's a fuse file system, we have the same basic building blocks. But in this case, the virtio-fs, the fuse server is in the user space, but in different machine, in the host, and the kernel size is in the kernel in the guest inside of the virtual machine. So we need to communicate those. We cannot use the same device. So instead we use a virtual device that usually has two parts, the driver and the device. But actually, virtio-fs is a vhost user device. So that split the device in two parts also, the front end and the back end, and we communicate those using a Unix socket. For that Unix socket, we only use the vhost user protocol. And using that vhost user protocol, basically one of the most important things that we do is to set up a shared memory region with the virt queues. We will use that virt queues to send the fuse command from the kernel guest to the fuse server in the user space in the host. So the whole picture is something like that. So now the application, when it does some file system operation, it will be handled by the POSIX file system in the kernel. That will call the fuse client in the guest kernel, and will send an operation to the fuse server in the host user space via the virtual device and the virt queue. So easy peasy, basically. So, okay, that is more or less a very brief description of each part, how it's fitting in this scenario. Future plans. Well, first, live migration support. Now is our top priority, at least the basic support that was Hannah was talking about. We also want to make easier for people to use virtio-fs not only to, for example, implement other types of file system, not only pass-through. We have some people that want to use like a native NFS client, for example, or CEF-FS. But also if you want to include your virtio-fs inside of your VMM. Like, for example, we have a project now that they are including the virtio-fs functionality inside of Cloud Hypervisor, for example. So that is one of the things that we want to make easier. It's possible now, but it's kind of not easy. Also, we are working to remove all the sandboxing code for the virtio-fs and use an external tool that will make much easier to be included in a container and all other stuff, because usually virtio-fs is already run inside of an external sandbox. So that is to simplify also the use case. Also, more in the future, we have this virtual vhost user support. That is the idea to have, instead of having the virtio-fs in the host user space, that will be in another virtual machine, in the user space of a different virtual machine. So the communication will be between virtual machine and virtual machine. So you can share a resource from one virtual machine to another. That use case, for example, was asked for people that has drivers from some file system inside of the virtual machine, but not in the host, and they want to access those using virtio-fs. Also, we are working on read-only sharing, IO urine support, to coalescing operation to make it faster. And also, we think it will be nice to have the iNotify stuff that probably allows us to implement more features in the future. So basically, that's it. 1 minute before the mark. So thank you.
So more of a comment than a question. So the feature you were talking about of trying to make it a crate is something that is also used by the Rust version of the runtime for CADA. And one of the reasons for doing that is essentially to bring in process, in a single process, things that were running in multiple processes before. One of the issues when running virtio-fs as a separate process is that you can have, for instance, a low memory condition where virtio-fs crashes, but QEMU is still there, or the opposite. And then these are situations that lead to really confusing error messages, and it's hard to recover from that. So there is also sort of simplicity for the user of value to being able to have that in process.
Yeah, that's a basic idea, basically. You can do that now, but it requires more work that is really needed.
How complex that would be to migrate the inode information, and does this make sense to live migrate the virtio based FS? So instead for use cases, maybe a block thing, virtio pmem or something else could be used just and input. Yeah.
So I didn't get the question fully. Like for live migration?
Yeah, you mentioned about virtio FS live migration future work. So
Yeah.
first question is how hard it would be to implement that or get it correct?
I mean, we're fully correct. And we're currently working on implementing it. So we already have a working prototype, basically. But it's well, the biggest problem basically is its work across all layers. Like we have Rust grades that do the VOS user stuff. Then we have to extend the VOS user protocol in QEMU. So it's just taking time. I don't think it's very hard to get something done. It's taking time. And then we have all these problems about correctness. Like,
And for the use cases mentioned, does this make sense to use a block-based
to use what?
block-based solution like virtio pmem or something for use cases?
We haven't
some of
looked
the
into
use
this
cases?
yet, but so.
Okay.
Just want to say, I think in some cases people actually want to share the directory and not necessarily like block devices. I think this Kubernetes case, they want to share some secrets with the VM, but they also want to basically do something like refresh the secrets. So having a block device makes it really harder. Sharing a directory makes it really easier. So there are some use cases where you need a file system based interface and not necessarily block based interface. So it helps with those use cases.
Okay. Yeah.
Thank you, manager.
So for the case where you want to migrate a file that has been removed, I think you mentioned the ability to delay the link from, so what you would say is something like, I know that this file handle is in use, and I just keep the file around so that I can reopen it on the other side. But the obvious question then is, what is the name of the file on the other side?
I mean,
How do you-
also the question is like, what is if someone else deletes it
Yeah.
outside of virtio-fs? Like,
So you can't completely hide it. You could hide it on the source, but on the destination it's harder.
yeah, as I said, we haven't really looked into this yet. Just brainstorming, just oh, these are problems, and yeah. So we're happy for input on this, right? But
Yeah, or
Maybe you can drop another file, some link to it, so that like original file will be gone, but my temporary file will be around, so I can still find the destination. I know, crazy idea, but dropping more files in a big file system will be a problem. Yeah, so like maybe something like NFS silly rename files, like
yeah, probably we
not
need to do something similar.
or prefix it with something, and if FSD is specific, and just hide all the files when the lookup comes. So, but none of these are elegant solutions. I'm just throwing them out there, and like,
Yeah.
if you ask me to implement it, I probably wouldn't do that.
Basically, we now want to, since this is like a big problem with a lot of corner cases and weird interaction and stuff, we wanted to be concentrate only in the simplest case. That is, we have lots of assumptions. For example, is both in the target and in the source in the target we have the same files, and those didn't disappear and didn't change the name or anything. So it's kind of that, especially for the kubevirt use case with service accounts and secrets, that is what we can expect. So it will work if you do some modifications, mostly, but we are attempting to solve this for like a read-only case. And we expect that nothing changed from the moment that you shared that directory to the migration. That is the first thing that we want to solve. The rest is just speculation though what we do. But yeah, we have a very clear case for that is NFS, that there is for them, except for NFS version 4 that is not implemented in the server part. I tried it unsuccessfully. Is the silly name stuff. So yeah. Also, it's not only that. Is if we want to support the temporal files in the open, that you don't even have a name when you create that file. So that's another case that we should support in the future.
Okay, thank you.
Thank you.